All right. Hello, everybody, and welcome to today's session, Jumping from Reactive to Preventive Maintenance. We are so excited that you could join us today. A couple of quick housekeeping notes before we get started. Yes, this webinar is being recorded, so you will receive the recording in your inbox at the end of the session that you can view at any time on demand. Q&A will be at the end of the session, so if you please could put any questions that you have in the questions tab. So you'll see on the right of your screen, there is a chat tab, questions tab. Use that questions tab to submit your questions as they come up. Joel and Henry will be able to answer those at the end of the session. And please tell us how we did. So at the end of the session, I will be prompting you with a link to a quick 2-minute survey. We'd really appreciate your feedback to make sure that we can keep providing these awesome sessions for you guys. And now I'd love to introduce our speakers. So I am joined today by Joel, Levitt, and Henry. Joel is president at Springfield Resources and has over 25 years of experience in the maintenance industry. He has trained people from virtually every one of the Fortune 500 and for most of the global 500, which amounts to over 17,000 maintenance professionals worldwide. Has given a number of workshops in more than 39 countries, and we're so thrilled to have him speaking with us today. Welcome, Joel.
Thank you.
And Henry is our senior product manager here at UpKeep. He leads the product development and strategy for UpKeep's core applications. His experience includes building financial, marketing, advertising, and maintenance products across many industries over the globe. And Henry, thank you so much for joining us today.
Thank you, Mara. Happy to be here.
Yeah. And I myself, I'm Mara. I'll be your moderator today. So if you hear me chime in at the end with questions, that's who you're listening to. So Joel, I'm going to pass it off to you and take it away.
Okay. Thanks a lot, Maura. But you put something up there. I don't know whether you meant to do it, but you said that I should check my hair before I go live. And I checked it, and it's not there anymore. Henry wanted for me to talk about going from reactive environment to a PM environment, and good luck with that. It's a tough go, but it is possible. So let me talk a little bit about this. I want to start off by a mea culpa. I'm guilty of something. Reactive maintenance and failures and lack of reliability. The thing I want to say goes against every text you've read, and some that I've written. And I've been wrong about this for 25 years. So I hope you stay on after this slide to find out how this works. But here's the deal. When we're talking about reliability, you can't ever PM your way to reliability. You can't plan and schedule your way to reliability. You actually can't write a check for reliability. There's no IIoT scanning sensors that'll get you reliability. In short, there's no bullet. There's no silver, gold, platinum, rhodium bullet that will give you reliability. The problem is that you live in a world with defects, and they're constantly coming in, and the pool is, for some of you, it's above your head. Some of this pool is made up of unfunded maintenance liability. So some of the problems are things where you removed wealth from an equipment without putting maintenance dollars back in. And then you have some systems currently that remove the defects from the pool. And these are things like incoming inspection to catch problems with raw material, preventive maintenance, operator training, and those things contribute to the outflow. But the thing I want you to get here is that you have a giant pool of defects that are ready to poison your maintenance and operation. And currently, without really looking at this, your defects are flowing in faster than you're removing them with the PM and training and checking incoming material. So the only thing you can do to improve reliability is to reduce the number of defects entering your system faster than you're adding them. So focus on defect elimination. That's part of the role of the PM system. Focus on the remediation of the causes of the defect. And then to keep the defects out, focus on doing jobs correctly the first time. So you don't see, the thing is, when we have a defect, it's generally the result of some kind of careless work habit. There are a few percent, like 15 or 20%, that are wear and tear, that something wore out. But most of the things that we deal with that turn into reactive maintenance, most of them overwhelmingly are some kind of carelessness, either on the part of the maintenance technician, part of an operator, part of a design. All those things contribute to the defects. So focus on reducing the incidence of careless work habits, and focus on like right from out of the box, like making sure you have the right equipment for the job. So how do we do this? Okay. This is, the fastest way to improve reliability is to catch reactive events before they happen. So do your corrective maintenance. Now, I'm using the phrase corrective maintenance in a very particular way. When I travel, corrective maintenance is sometimes fixing breakdowns. In this sense, in this discussion, when I use the phrase corrective maintenance, what I mean is maintenance that is problems that are detected by inspection and fixed before failure. That's corrective maintenance. So you have your PM people go out and they look at things, they touch things, or they read instruments, and that's where corrective maintenance comes from. So all that stuff that's in the hopper, it needs to be done, because those are the defects which are going to go to failure in the shortest amount of time. PM helps you in 3 big areas, which we'll look at. And then the discussion about precision maintenance actually keeps the pool from getting deeper and deeper with these, terrible bugs, monsters, whatever you want to call them. So the 3 big ways. One is, some of preventive maintenance is specifically designed to extend the life of the asset. If I say to people, well, what in PM extends the life of an asset? And somebody will always say to me, taking a vibration reading or reading an infrared scan. And I say you can take vibration readings every day and still have the same number of failures, because taking the reading does not remove the probability of failure. It just tells you that it's going to fail. But there are some things that you do in PM which will actually make the asset last longer. I call them TLC: tightening bolts, lubrication, and cleaning. Those 3 things, TLC things, actually in themselves extend the life of the asset. In fact, they remove, like, one defect is that there's no grease in the bearing. One defect is that there's dirt and there's contamination. So TLC, tighten, lubricate, clean. And then you have the second part of it is you detect problems of deterioration or something is wrong, and that's through inspection. And inspection can be any kind of inspection. We can have inspection for, by touching something, by feeling the vibration. In a paper machine, the guys there would do their inspection literally with their feet on the catwalks as they went around the machine. They could feel the vibration, and they could feel whether the rollers were balanced and aligned and everything. So there's senses of feeling. There's the sense of sight, being able to look at something. If I look at your PMs, I'll probably say inspect. It'll probably say something like inspect X. Now that's a terrible PM task, because it should always be inspect X for Y. It should always tell you what you're looking for. Or if you're supposed to read a reading, like read the amp meter and write down the number of amps. That should always say write down the number of amps, and then good is between 100 and 110 amps, so that the person doing the inspection knows that this is abnormal situation. So we've got extend the life of an asset and inspect to detect defects. And we then can do a short repair. Now, a short repair is where we actually fix the defect. We fix it properly. It just doesn't take very long. So it could be that, you have a pill block that's worked its way loose, so you torque it up. It could be something as you can tell the wire is a little bit loose, that the block has, changed a little bit, the screw backed out. So short repair. Now, short repairs are really productive if you're allowed to do them. In some cases, those of you with dangerous environments, you're frequently not allowed to do any repairs unless you've, gotten clearance to do them. So if that's the case, you can't do that. But for a lot of people, a short repair might be 15 minutes or less. My personal rules are that the technician doing the PM must have the tools and any spares that they need with them. So I recommend in a lot of cases to have like a cart, a PM cart. So it has some tools, it has some, items that you might need. Very, very productive, because remember, if you do a 10-minute, half-hour repair, that probably there's a half hour to get ready to do the repair and do the lockout and go to the warehouse, all the stuff that you have to do that 30 minutes worth of work. Well, if we're doing a short repair, we're already there in front of the machine. We've already got custody and control of the machine. It's already in a safe state. So we're golden. We can just work, and that's pure productivity. That affects what's called the wrench time. So it makes the wrench time really nice. That's a short repair. If you can't do it in a short repair, you have a longer repair, which is called a corrective maintenance work order. So the PM person, writes up, or they're on their mobile device or however it is, but they create a work order to do the work that fixes what they found. These are the unfunded maintenance liability items. Now, 99% of the PM systems that are out there, and I say 99% because I haven't seen all of them, so there may be some that don't work this way, but all the ones I've seen work this way. You start over in the green, you have a CMMS has a PM task list that you've created. Now, if you know your reliability engineering, the task list is detecting failure modes that you've determined are problematic. So you go down the tasks, and task 1, task 2, and then one task says, check out the bearing somehow, either through vibration or get a screwdriver, put it on there. So now we say the inspector sees, hears, or feels something's wrong with the bearing somehow. So what they do is it can't be done right then because it's too big a job and he doesn't have the parts. So the inspector writes up a corrective order to remove and replace the bearing. And that corrective order is linked to the PM task list work order. The job enters the backlog. Now, corrective work is the primary source of backlog. The job is planned and scheduled because we're really good people. We do everything we're supposed to do. And we remove and replace the bearing. And then we wait until the task list comes around again to check it again. That's it. That's the PM circuit. And this is how it's tied into your CMMS, that this task list is initiated by some kind of trigger. And the trigger could be a calendar, could be a 30-day calendar or annual, or it could be, the trigger could be production or hours, hour meters, any of the things that, kind of capture how the asset is used. Now, when I say detect deterioration, I want to go get fancy for a second, okay? So what happens nowadays is there's many more people that are using IIoT sensors, that's Industrial Internet of Things sensors, and they can sense all kinds of things. I mean, I have a book of like hundreds of things that they can sense. So this is really a burgeoning field, and there's a lot of excitement in the field. But if we just follow how this works, in the high-tech world, the woo-woo world of artificial intelligence and analytics, the way this would work is that there's a thermometer sensor on the machine that has either a wireless output or it's wired to an edge computer that's right on the machine. So it could be either way. Sometimes you use an edge to consolidate the several sensors into one packet of information to send. So the edge computer shoots the sensor data to the cloud, or the sensor goes directly by Wi-Fi to the cloud. You can see the cloud it looks like it's going to rain. Inside the cloud, there's software, analytics software, and there's AI software in the cloud. And what happens is it reads all the data coming in, and then it sends out an alert to replace a bearing. That would be prescriptive maintenance. That would be a work order, really. So this is the fancy end of it. This is not necessary to do what I'm talking about, but some people love the tech stuff. I'm one of them, and it makes it way more fun, right? Now, maintenance folks are reality-based thinkers. Now, let me just, I run into people, in sales and, in corporate leadership, and they like to build a wonderful picture of the world that unfortunately does not now exist. Maintenance folks are hardcore. We're down in the trenches. We're dealing with concrete reality. It's like there's people that think if you yell at a machine, it won't break, or it'll get better. Well, we know that that's not the case. So the sins of the past are the machinery that has been running fine, but it's getting deteriorated in various ways. And you're not putting the money back in to keep it in, like new condition. So this is where your pool of defects lives, and it's called unfunded maintenance liability. Part of PM, as I've been discussing, is designed to detect and report these kinds of problems. So if we look at time, if I build a PM system, many of you have built PM systems in your careers. The benefit of a PM system, we usually say, is 18 months after we put it in. 18 months. In other words, we have to do PM for 18 months before we'll see any advantage from it. And the reason for that is that all you're doing when you do, PM in this case, is you're removing defects and you're avoiding defects from starting. So if you avoid defects from starting, you won't know that you did that for a year or a year and a half. But if you concentrate on all the defects that you can see, that's your corrective maintenance work orders, that impact will be literally next week, next month, because those are the things that we're going to break. You have a little bit of chatter in a bearing, and that sucker's going. It's just a question whether it's a month or 2 months or whatever. So if you look at I'm pointing to my screen, which of course you can't see, but if you look at the timing, the corrective maintenance, being really rigorous about doing your corrective maintenance and looking for corrective maintenance, not only just doing it, but really being vigilant about corrective maintenance and then dealing with it, that will carry you until the TLC and the life extension tests start to take over, okay? So now we're managing to reduce the number of defects entering the pool. We've got to keep those suckers out. Now, these defects, I view them like bugs, like nasty little bugs. They come in, there's 5 species of bugs. There's bugs that come in on raw materials. There's bugs that come from misoperation of equipment. There's bugs that come from craftsmanship issues, bugs that come from bad spares, and bugs that come from design flaws. So to keep these suckers out, we have to start thinking in terms of precision. Now, precision domain, it's a kind of a funny domain to talk about because it's a domain where nothing happens. When we look at why things happen, we do root cause analysis and we see what is going on. We have reactive, we have preventive, predictive, all this stuff, but they're all based on something having happened. With precision maintenance, the thing that happened didn't happen. So precision installation, like alignment, like balancing, like assembly, precision bolting. So we torque the bolts to the design torque. Precision lubrication, the right lubrication delivered in the right amount at the right cadence. Precision spares, OEM or better. I mean, if you have a manufacturer that makes a better spare than the OEM, by all means. It's just that we can't buy spares on price, from a junky supplier. Precision housekeeping during the repair. We go into places and literally the repair looks like it's an operating room thing. It's like they drape stuff that they're not using. They'll put tape up and stuff so that debris doesn't fall into the repair, particularly, if you're on the shop floor. And then the biggest one is going to be precision operation. So precision operation. So it's pretty cool. PM removes some defects through TLC because we're cleaning stuff. So some of the defects are dirt or contamination. PM has detected some defects and removed them with short repairs. PM has detected some defects and issued CM work orders and removed them from that. And then precision maintenance keeps the defects from reappearing. So I think it's time for a little bit of a cat nap there, folks. So let's turn it over to my dear friend, Henry.
Thank you, Joel. Thank you. Yeah, so awesome presentation. Now I'm going to walk you guys through a little bit into UpKeep and how you might be able to do some of the things that Joel was just talking about. So I'm going to go ahead and share my screen. Make sure I do this right. Awesome. So what we're looking at here is the UpKeep system, and specifically the preventive maintenance section inside of UpKeep. What you're going to see is a long list of different PM schedules that I've created in the past. But what we're going to do today is just walk through really how easy it is inside of UpKeep to create a PM schedule, do an inspection, and trigger a reactive work order off of that. Because as Joel mentioned, setting up the PM might not be, there's a lot of research that has to go into it, a lot of thought that has to go into it. And what we want to do at UpKeep is make it as easy as possible for you to actually execute those. So I'm going to go ahead and create what we call a trigger. A trigger is basically a PM schedule. It could be based on completion, it could be based off a reader, it could be based off a set schedule. Today we're just going to be inspecting the boiler weekly PM. So this is a PM that will go at once a week to just really inspect the boiler that maybe you have somewhere. So we'll go ahead and title the actual work order that goes to the inspector, which is inspect boiler. Follow task list, set a priority, maybe medium, and then we're going to go ahead and actually assign that boiler itself. So we're going to vertical boiler A384, which is on the 3rd floor. We're going to assign the inspector to go ahead and look at it. And then the most important thing here is actually assigning the tasks and checklist that matches this. So one of the things that you might be doing when you're organizing your preventive maintenance is defining what actually goes in to the various tasks that you see, just as Joel kind of pointed out. So we'll go ahead and add these 10 tasks, these 10 things that you actually need to inspect. This will probably just take about an hour to go through each of those tasks. We'll don't need to fill out too much information. We're going to start it this week. We give you a ton of options on like the cadence you want to start it. Maybe it's quarterly, annually, on the last day of the month, on the first day of the month, really anything you want to do from a scheduled cadence. But this one's going to go back to weekly, starting off today on Tuesday. And this is just going to go in perpetuity. You're going to keep inspecting this boiler. We're running it to failure. So really until we take this offline, we're going to keep the trigger going. So I'm going to go ahead and create this trigger now. You'll see hopefully successfully created. Then we can look at it, make sure that everything looks good, make sure to already trigger the work order that will be going out to the technician who needs to actually do it today. And then we can also see the calendar, you'll see the future work orders that will be triggered. Maybe next week, because it's Thanksgiving, I'm actually not working on Tuesday. You can easily actually just adjust this so it would actually trigger for that Monday. Don't want to get too much in the weeds there. But the next thing I want to show is actually the inspector or the technician's view. So a big part of UpKeep is we are mobile first. Everything happens on the floor. You don't always have a computer in front of you. And so we've taken a lot of time and a lot of thought on creating a mobile experience that streamlines the workflow as much as possible. So we're looking at here is this actually went to the technician or inspector who was assigned this PM trigger. They could go ahead and see what was due today. You'll see it pop up right here. It's an open work order that's due today. It matches everything that you saw us really putting out before. So to get there, we're going to actually start working, put this in progress. It starts the timer so you can start tracking actually how long it takes to make sure your estimates on your PM schedules match the actuals of the work that's going in. And then you're going to go ahead and actually just start your tasks. So you're going to see a number of different tasks as we talked about. I don't want to go through them too crazily, but the technician basically goes in and maybe they fail some things. So let's just say the very first thing they look at, this actually fails. It doesn't, the burner shut off doesn't go correctly, et cetera, et cetera. They go ahead and finish the rest of their PM. But basically what we're seeing here, this fail, This part's the really important part because you don't want this information just to get lost. Okay, it fails. What's next, right? And so what UpKeep does is we actually will create the work order based off of this failure point using one of our automated workflows. So if this task fails, UpKeep now knows that, hey, you need to go maybe replace, as Joel mentioned, replace a burner, replace a valve, do something based off of the fact that this task went ahead and failed. So let's just say we complete our PM. It actually only took a minute, not an hour, so that's great. But we can actually go in back to just the list of what's been updated, what's been created. Let's see here. And you'll see that this form item of that thing failing actually created its own work order, went ahead and attached it to a technician. Maybe it's something that automatically gets a really high priority because it's super important. Maybe it's something that doesn't, but this will create that reactive work order based off of the PM inspection that had failed based off of your weekly PM. So this will give you a really good starting place on your preventive maintenance from a CMMS standpoint. But how do you make sure that you're actually following that? How do you make sure that not only are you seeing this, the machinery, the assets, the equipment not break down, but making sure you're compliant with your PM schedule? So what we have here is actually a maintenance compliance graph. This maintenance compliance dashboard showcases, how many work orders went out, how compliant you were, and we define compliance as finishing before or on the due date of the work order and actually getting it to complete, and how many were not compliant, how many may be still open, maybe they weren't completed on time. Different people will tell you different KPIs to aim for. On the product team, which we're not the maintenance and reliability professionals, that's you, but we always say, hey, anything above a 90% looks pretty good. And then maybe you want to go a step further and actually see where are you failing? Where's this compliance failing? And you can see, our medium priority, 6% of our work orders have failed. We can drill into that and actually see the assets that are non-compliant. It looks like it's this HVAC unit right here that might be incompliant, but it looks like it keeps, we do a lot of PMs on it, but we don't finish them all. This completion rate's really bringing down the rest of our system. So this is just a high-level overview of all the different things of basically a workflow that matches what Joel's saying. Our PM system, can go a lot deeper. The tasks and checklists can go a lot deeper. I don't want to bore you too much with that, but just to reiterate kind of the path that we showcased. We created a PM. This triggers once a week. The first one was triggered for today. It then triggers the rest of them after it's been completed. And then what we've done is the work order actually appeared here on the technician's workflow who's now completed it. Because one of the inspections failed, we actually created a reactive work order to go fix whatever failed from that inspection. And then we saw how compliant we were looking back on everything that happened. So that's just a quick overview of UpKeep's preventive maintenance. If you want to learn more, we do have free demos, free download, free trial of everything on UpKeep. So yeah, happy upkeeping and happy preventive maintenancing.
All right. It looks like some of you have been posting some great questions in the chat in the question box. This is a reminder to keep those coming while we go through them, and Joel and Henry can chime in on those. So the first question that I see is, this is from Edward. This can be overwhelming when you seem to be constantly putting out fires. I've inherited a system that didn't do PMs correctly. Any idea on how to overcome this?
Well, Edward, that's a really good question. Am I on?
Yes, we can hear you. Yep.
It's difficult, but not impossible in an environment that you describe to bootstrap your way into this by taking a small percentage of time, like 1 or 2% of the time that's available, and devote that to getting rid of the defects that we've been talking about. So eventually, and the statistics show it takes a couple of years to do it that way. So what I recommend to people is to start below the radar. In other words, find somebody who's interested in this kind of stuff and let them, work on this. And when you get some successes under your belt, write it up and present it to management with the savings and, you know, everything that happened, and try to get some budget to like wholesale deal with the deteriorated equipment, and then straighten out your PMs too, you know.
All right. Next question is from Felix. He says, is it good practice to go for corrective maintenance right when we detect some defects during PMs, or should we wait until we have a shutdown to do those corrective maintenance tasks?
Well, that's going to depend on your environment. If you're in a, like, let's say you're in a power plant, well, you're going to have to wait for a shutdown to do most things, because you can't just take the boiler offline, you know, just to fix a little thing. So, but in many kinds of maintenance, they actually, like, if you took care of trucks, for example, you would do your service, and then you would, anything you found during your service, you would fix it right away. But you don't want trucks out on the street, you know, with defects on them. In a factory, the schedule becomes really important. So you may not have time to do it right then, but you may have to do some procurement. You may, you know, once you have to leave the site, it's not any more productive to do it later. It's not, you don't lose any productivity by doing it later if you have to go to the warehouse anyway. So if you can do it, it's great. It'll mean that you won't have as many, you know, breakdowns during that intermediate time. Some places you can't do it, and some places the schedule won't allow you to do it. Uh-oh.
Mara, I think you're muted.
You're muted.
I did. I said, thank you, everybody, for all your wonderful questions. Please keep them coming, and I will stay off mute. This question is from James. He says, hi, good evening. How could this work for my company with a chain of 9 restaurants? And how does this work for us in the CM arena?
Yeah, James, this is interesting, because with, you know, restaurants, you may not have, you know, it depends on the exact situation, whether you're having local people from the restaurant doing your inspections, or whether you're bringing a contractor, or whether you have a roving crew that visits each restaurant. What we do is, if it's a roving crew, we equip them to do virtually everything they need to do with what's in their truck, so that they can do the PM and then do the corrective right then and there. Because you don't usually the windshield time is the big problem with, you know, where you're spread over some area, you know, for restaurant work. You can see, you know, people like McDonald's and the fast food folks have really thought through their equipment, so they're, you know, they know what spares to bring. And I don't know your situation, but that would be something I would look at, to standardize the spares so that you can do more stuff when you go to get it.
Makes sense. This is an UpKeep specific question. Gloria asks, does UpKeep have generic task lists or checklists that can be edited to the specific equipment or location that I have?
I can probably take that one. So we do have a section on our website, which is on upkeep.com/templates. It's something that we've just actually released, and we'll be updating pretty constantly, and adding a ton more. And basically what these are is they're templatized checklists, inspections, PMs, that you can easily download and then import straight into UpKeep. And those will be a great starting place maybe for the generic tasks that you're looking for.
Definitely. Joseph asked another specific question at UpKeep. He says, for UpKeep CMMS mobile device interface, what would you recommend for the hardware? For example, an iPad, a Panasonic touchpad, etc.
So we have both Android and iOS compatibility. It's on both app stores. I'm a huge Apple guy, to be honest. I love my iPhone. I think UpKeep runs pretty much on almost all devices. You just want to have the latest and greatest operating system installed on your device, and it should work pretty flawlessly.
Awesome. A question from Chris. He asks, is there a way to create triggers or meters that can be mass loaded instead of doing it one by one?
Yeah, great question, Chris. So we do have import functionality for our work orders, which can also be added to our schedule-based work orders. For PMs themselves, we're coming out with a brand new import tool, hopefully later this year, actually right before the holidays, that will make it super easy for you to mass import thousands of PMs so you don't have to go one by one. So yes, and also yes.
Nice. Randy has a question. He says, any plans to convert currently created PM/maintenance scheduled work orders into a preventive maintenance trigger?
Yeah, great. Randy's probably a current UpKeep customer. So as I mentioned, our old maintenance scheduled work orders, which is what Randy's referring to, are the ones that you can currently import very easily. We will be actually transitioning and migrating all of those over into the preventive maintenance section. That'll be happening most likely sometime in 2021. So yes, there are plans.
Okay. Randy says, awesome, looking forward to it. And James says, thanks very much for the answer about his fast food franchise. So I think that was great. One more, we've still have time for a couple more questions. So if you have them, please do send them in. There's one more here that I see that we haven't answered yet. It is from Edward. So he's back with a second question. Thanks, Edward. How does he get more information on UpKeep CMMS? They're currently using SEP. So I can answer the first part to that question. Edward will send a follow-up email with information on how you can request a free product tour. And on the point of SAP, Henry, if you want to kind of chat about integrations.
Yeah, we're actually about to release officially integration into SAP. So look out for that if you guys are currently using it. If you're looking to come on over from something, we'll also be able to help via that product tour. Awesome.
So I don't see any additional questions. I'll give it just a couple more seconds. Oh, what is that?
It says precision maintenance. I don't actually know what this means.
Yeah, I'm not quite sure. Felix, we can follow up with you afterwards just to make sure that all of your questions have been answered and that there's no question left unanswered for you. I believe that's all of the questions that we had. So Joel, please, if you could go to the next slide. I think this might answer some additional questions here. So some next steps, please tell us how we did. I will be sending you all right now a quick link to our survey. So if you could, please fill out the survey. We'd greatly appreciate it. Just so we know what you're interested in hearing more about. We can do like follow-up sessions, anything like that. Just let us know how we did. We'd really appreciate that. For additional resources, you can check out our website for additional blogs, Q&As, customer stories, and more. You'll also find a link to our free product tour there as well. Please join the maintenance community on Slack. That link will be in the follow-up email as well. There's tons of free resources there and experts like Joel. And then lastly, plug for Joel here, please check out the Quest for Defect Elimination on Amazon. So if you enjoyed today's presentation, know that Joel has a full-length graphic novel on the topic of defect elimination. That's really awesome. And we'll also actually be raffling off a few copies of that. So check your inbox, could be a lucky winner. So thank you everybody for attending today. It's been a pleasure. Thank you so much, Joel, for joining us and for sharing your knowledge, and Henry. And we look forward to seeing you all again soon. Thanks so much.
Bye.
Thanks, everyone.
Thank you.
Thank you.